Okay, so to calculate the range of frequencies for visible light, we need some information. And in the textbook, we're told that visible light extends from 400 nanometers to 700 nanometers. So again, we use the equation that velocity is wavelength times frequency. We have the wavelengths, so to get the frequencies, we divide both sides by the wavelength. So the frequencies that we require are velocity of light divided by the wavelength, and as we have already established, to three significant figures, the velocity of light is 3 times 10 to the 8 meters per second. And if you are careful about significant figures, you might choose to write that as 300 point times 10 to the 6 meters per second. But I'll use the top form for brevity. Okay, so we need to work out the frequencies corresponding to the two wavelengths, so we can do that by direct substitution, but we need to remember that nano is a prefix, which means 10 to the minus 9, and therefore for 400 nanometers the frequency will be 3 times 10 to the 8 meters per second divided by 400 times 10 to the minus 9 meters. That's a direct substitution. The meters will cancel and we'll be left in an answer in units of per second, which also has a name of hertz. And if we calculate this frequency, we will find it is equal to 7.50 times 10 to the 14 in units hertz. So that is our first frequency. Our second frequency we find in exactly the same way, 3 times 10 to the 8 meters per second divided by now 700 times 10 to the minus 9 meters, and again the meters will cancel. The answer will be in per second or hertz, and in this case the answer to three significant figures, 4.28 times 10 to the 14 hertz. There is our answer, and as always, being nice to the person who needs to mark the problem, we clearly show what our answer is. And we're done.